Welcome to everybody. Welcome to this new video. Okay, here we are going to take the solution to the Math GC 2023 paper 3. Question number 1. Okay, so the question reads: a particle P of mass 3 kg moves so that its position vector r at time t second is given by r equals to t into 1 minus ti plus t into sine pi tj meters. Okay, find when t equals to 1, a the momentum of P, b the kinetic energy of P, c the cosine of the angle between the velocity and the acceleration. Okay, so let's proceed. We now go directly to the solution. Okay, so with that, we first of all have to expand r. Okay, so if you open the brackets in r, we are going to get t minus t squared I plus t sine pi t j. Okay, don't forget, here you have a trigonometric function that is sine pi t. Okay, you can just consider these two to be the angle. Don't mix this t with this other t. Okay, they are two different things. Are we okay with that? So when you open this bracket at this level here, the t must always be in front of the trig function. Okay, so let us answer the a part. Before that, let us first of all have the velocity. What will be the velocity now? Because the a part say calculate the momentum of P. So the velocity now here, we know the velocity will be equal to dr on dt. Okay, so we differentiate r with respect to t. So if you differentiate this r correctly, you're going to get 1 minus 2ti plus t into pi cos pi t plus sine pi t, ordered in meters per second. Okay, this square is an error, I think. Okay, thank you, sorry. Yes, meters per second. Okay, so what am I saying for this other part? Because I know most of us will reach at this part and get confused. Okay, so if you get this and we want to differentiate this, first of all, what do? We first of all differentiate sine pi t. Okay, so if we differentiate sine, what do we get? Cos. Okay, so now the angle, we are going to get cos pi t. Now you are going to get what? The pi here must come out. Okay, because pi there is it's just like the value beside the angle, because we are differentiating with respect to t and not to the angle. So it will be pi cos pi t other times the t, because we hold t. Now we differentiate now t and we copy back sine pi t. So if you differentiate t, you get 1, and you copy back the rest of the function, you get sine pi t. So that's how you differentiate this other part. So with that now, we know that what? We know that momentum equals to mass times velocity. So they gave us a condition when t equals to 1. So everywhere you see t, you just replace 1. Okay, here we get down a 0 because sine 180 is 0. Okay, so you can verify that on your trigonometric function diagram or table, or you can punch and you see you give you a 0. Okay, so we simplify the velocity and we get negative I minus pi j. So what is the momentum? The mass times the velocity. So it will be equal to negative 3I minus 3 pi j kilogram meters per second. So don't forget, here our mass was 3 and the velocity was this. Okay, when t equals to 1. So let us pass to the b part. The B part say calculate the kinetic energy of the particle P. Okay, so the kinetic energy is given by half mv squared. Now V is given by a vector in the form of a vector. So how do we do that? So to have now the V, the normal V, it will be the magnitude of that V squared. Okay, so you do the magnitude of the velocity that you have. Don't forget, still the same condition when t equals to 1. So you have half times 3 into what will now be the magnitude of V. It will be negative 1, that is the I component, negative 1 squared, plus the J component, negative pi squared. All that, don't forget, all that squared. So they say the magnitude of V squared. So if you simplify, you get 3 on 2 into 1 minus pi squared J. That is joules energy. Okay, so you're not obliged to replace the value of pi here. Okay, because naturally we know that pi is 180 from a trigonometric function. We know that pi is 180, but you can work with it. Let it not disturb you. Okay, in A level we must learn that we are always working with constants. Okay, we must be used to. Now let us pass to the C part. We are asked to calculate the cosine of the angle between the velocity and the acceleration. So with that, let us first of all have the acceleration. So what will be the acceleration? The acceleration is given by dv on dt. Okay, what does dv on dt equals to? It will be equal to negative 2i. So you will differentiate again the velocity, this velocity here, before you replace your time. You differentiate again. So here you still have a bit of palaba if you are not ready to learn or to understand what is happening. So you still differentiate with respect to t. So if you differentiate cos pi t, what do you get? You get negative sine pi t Okay, the pi now will come outside, so you get negative pi sine pi t. Okay, now not forget there was this t and this pi, so you just copy back there and you multiply by it. So because we are differentiating first this part, now you will differentiate now t. Okay, you differentiate now t. If you differentiate t, you get 1. So what are you left with? You're left with cos pi t. Okay, so that's why we are saying plus cos pi t. Now with that, now what do we have? We have this pi here comes from here. Okay, comes from here. So now you differentiate this other side. You're now differentiating sine pi t. When you differentiate sine pi t, what do you get? You get pi cos pi t j. Okay, that's for the two components. Okay, yeah, I've not indicated even the I component. So but that is it. Okay, we have that. So okay, I indicated it here. Okay, so the equation is so long that I'm not more saying. So we have negative 2i. Okay, so we have that. You simplify, you have the new equation to be equal to negative 2i plus pi squared t sine pi t plus 2 pi cos pi t j. Okay, now we swap to the calculation. Now we say when t equals to 1, we replace the value of t now in the acceleration, and we are going to get what? We are going to get the acceleration to be equal to negative 2i minus 2 pi j. Okay, so now let me just use this assumption so that we should work with an angle that we know. Okay, let the angle between v and the acceleration, velocity and the acceleration, be theta. So what will be cos theta? Cos theta will be equal to v dot a divided by magnitude of v times magnitude of a. Okay, so you copy your v, your velocity, you copy your acceleration, you multiply the two, you divide them by the magnitude of the velocity times the magnitude of the acceleration. So for this other part, you are going to do it. Okay, you're not doing it for me, or it's for your own good, because I did it already and I saw the answer to be equals to 1. So you just have to open to do the magnitude and simplify, and tell me in the comment section if you have the same answer. Okay, but now what you need to note, the question says find the cosine of the angle between v and a. Don't go and you start finding the angle. Okay, they say the cosine, so don't do cos inverse of 1. Okay, you start getting funny answers and you'll be questioning yourself. They say the cosine of the angle, so you they want for cos theta and not theta, so that answer will be equals to 1. So now that is all for the video, and I present myself and Mr. Wilson. So I thank you all guys for watching. Okay, don't forget, like, comment, share the video, let the video go far. Okay, let many persons be able to see what is happening here and analyze with us. So I thank you all again. See you in another video. Thank you.